Oh, good morning, um, Brother Macbeth. This is. Oh, wait, isn't this supposed to be in the get ignore? I'll figure that out later. Um, for now, this is my Rust program. So this function shell calls these other functions if 2 times 3 is 7. That's just to get the compiler to stop complaining about the unused code. I don't like the way that the compiler treats warnings like errors. I find that annoying, so I just have this dumb little workaround. So a lot of the code here is stuff that I found online just to look at and try and understand how it works and to benchmark it against my own code. The first function I wrote was following a tutorial to make a guess the number game. So I can do cargo run here. And I will say 42 because I'm contractually obligated to start with that number. And then there we go. So that's the guess the number game. That one's really simple. And then I'm gonna do this one next, even though this was like the second to last one, just because it's. Wait, what? Oh, right. I had to. Okay. This one did something really weird. I had to import a crate to allow me to allocate stronger numbers. But to get this one, this had to be 32 for it to run without crashing. I'll just demonstrate that real quick. Change it to 32. Run it again. And you'll notice it takes a lot longer to compile this time. It's going to say building 16 out of 17 for like a good 5 or 10 seconds. And then eventually it will compute and print Fibonacci numbers. Yeah, see, I think that's more like 15 seconds. It computes Fibonacci numbers until a second has elapsed. That was the way I decided to cut that off because it's more fun than just picking some arbitrary, like, only calculate 100 numbers. So yeah, I had to install a crate just to do that, but it slows the compiler down when the number is big, even if the code never runs. So I keep it at 8 if I'm not running it. And then collapse. What that does is it does a thing. It's from the Collatz conjecture where you take a number and if it's odd, you triple it and add 1, and if it's even, you divide by 2. And this, since 3 times an odd number plus 1 is always even, I've combined 3x plus 1 over 2 as a single step, which is why you're not seeing 16 here, and it's just jumping straight to 8. If I do, what is it, like 27 is the one that, yeah, that goes all the way up to 4,616 and technically higher. It's like 9,000 something before it finally goes back down. So that's cool. And then if I say something that isn't a number, it'll exit gracefully. And then the last one is this bad boy, and I'm going to just dial that down a bit since OBS is already using up system resources and I don't want my laptop to melt through itself. I'm going to only go up to 100 million instead of a billion. Did I actually call it? Okay, good. Couldn't remember if I had. And you can see it takes 2.62 seconds to actually cull the composite numbers, and then an additional 0.3 seconds just to figure out, like, hey, just how many prime numbers did I find anyway? If you just wanted to find the biggest prime number below the target, that extra 0.3 seconds wouldn't exist because you would just start at and work backwards until you find one, and that would take a negligible amount of time. So yeah, this code isn't very exciting. It's just a bunch of silly math experiment functions just to learn the syntax of Rust, because I had a hard time learning the syntax, and I don't really know how it's possible that it's been 10 hours, because I feel like I barely got anything done. I mean, yeah, there's a lot of code here, but half of this is copy and pasted from Rosetta code. This here, the crazy fast sieve that I found online, and found out it was written in like 2016. That gets up to 1 billion in like 5 seconds, which is crazy. But yeah, I think that's everything I had to show.